Okay, so let's go ahead and continue our discussion with Europa. So this moon, traveling around or orbiting around Jupiter, orbits and rotates every 3.5 days. So again, it is tidally locked or has synchronous rotation. Its surface is mostly solid water ice and is crisscrossed by fractures. And we can see that in all three of these photos, actually. So if we look here at A, we have icy crust that is or was relatively thin, where possible liquid or slushy ocean is beneath the surface, and ice blocks may have slid or rotated from original positions to create these sort of uh, fractures or yeah, fractures in the ice, okay, in that icy surface. So we see that over and over again in these images, okay, and this is something that we are still studying, we're still looking into, but it is something to point out, okay. Um, there is a subsurface ocean that may contain more than twice as much water as Earth. So the last one we talked about, Ganymede, I believe, that one had more water. This one may have twice as much water as Earth. It has an extremely thin oxygen atmosphere. Um, like I have said, it has liquid water, abundant energy and chemical elements that make it one of the best places to seek life beyond Earth. Okay. And again, this is obviously all of these are still being studied. So it's kind of interesting to see that progression of when we study more and discover more and more. Okay. So images like this, we can see that relatively thin surface that has probably a liquid or slushy ocean beneath. All right, and let's talk about Io. So Io is going to be closer to Jupiter. That'll be the closest. It rotates and orbits every 1.8 Earth days, and again is tidally locked or has synchronous rotation. Um, this is the most volcanically active world in the solar system. Okay, it has lakes of molten silicate lava on the surface, and maps have revealed more than 100 recently active volcanoes. Okay, so we can see that in a lot of images of Io. So this is an image taken obviously farther away and has pretty good resolution, and we can see what look like little holes or dimples in the surface. And in this case, this um, object or this moon is so volcanically active that they're most likely not going to be craters. They're going to probably be another place where there is um, molten lava on the surface or a volcano is present. Okay, so we have even witnessed it. We have a couple of images here of eruptions happening on on the surface of Io. Okay, so we can see it here. We have some change in the surface, and here we can even see it going out into the atmosphere. Okay, um, the atmosphere is very thin and primarily made of sulfur dioxide, which is going to be a product of the volcanism on the surface. Okay, and due to that, and due to so much of the activity that happens there, it won't support life as we know it. Okay, and remember, this is all going to be a question of life as we know it, since we know life as being very dependent on water and oxygen in the atmosphere. So, in this case, we don't know of any life that could survive this. Okay. Whoops. This image on the bottom, I just wanted to point out, has this lake of lava, really. It's breaking through the surface here. And so I just wanted to kind of point that out. It's very interesting to see it um, just on a different world. Okay. All right. So why is Io so volcanically active? And there are maybe some other moons that have this same case, but um, Io in particular has such a active volcano like system because of tidal heating. So with the moon and the earth, we have um, this relationship to where the moon kind of how am I trying to say this? It makes us have tides, right? For the water tides. This is very similar but more extreme. So Io is pretty small and it's really close to Jupiter, which is very large and so has a very a great um gravitational field around it. Or yeah, gravitational force. There we go. So the gravitational force is so strong with Jupiter acting on Io that it's like flexing and heating the interior of Io, and therefore it is almost completely melted, and the crust is constantly being recycled due to volcanic activity. Um, so this tidal heating occurs when orbiting bodies create heat due to the constant pulling of gravity between the bodies. Okay, so this is what we have on Io. So it's very interesting. This is why it's so hot. It's not that it's close to the sun, right? It's much further from the sun than, say, Earth, but it has this constant flexing and heating of the interior of Io. Okay, so let's talk about Saturn. So Saturn has 82 known moons, okay, and I'm not going to list them all, okay, but we will hit on one in particular, which is Titan. That's going to be the largest of them, and it's almost the size of Ganymede, so to give you kind of a reference, it is the only moon with a substantial atmosphere. And the lakes or seas are of liquid hydrocarbons like methane or ethane that are on the surface. Okay. It has six other large regular moons that have diameters of 400 to about 1600 kilometers. Okay, so let's quickly talk about Titan. So, like I mentioned, the surface here. Okay, we have an icy surface um, with rock hard ice water, but likely has liquid water underneath like an ocean. Okay, just like we have talked about before. And we can see the higher this in this image, this yellowy color, this yellow-like color, I should say, is going to be your regular surface, and then the blue will be where we've got ice and possibly water underneath. Okay, so you can see that in this image. This image over here shows another depiction of the surface and the all the way up to the atmosphere. So it kind of breaks it down into how far away you are from the surface. And it's just kind of interesting to see this the formation of these um, how do I say it? The formation of the surface, I guess you could say, and also how high the atmosphere is. So it the atmosphere is very substantial, and it's the only moon in the solar system known to have this, and it's mostly nitrogen. Okay, so it's mostly made of nitrogen, which is very similar to Earth. So Earth has about 70% of its atmosphere is nitrogen. So this is very similar. So this subsurface ocean that we talked about a bit ago may be a place that life could exist. And it is another one of the most hospitable worlds in the solar system. And that's due to that fact that there is liquid water, liquid water beneath its surface, and this atmosphere being very resembles Earth. Okay. I did also need to mention that it orbits and rotates every 16 days. Again, tidally locked or has that synchronous rotation. All right, let's quickly talk about Uranus. So Uranus has about um, 27 moons. Okay, it has 27 moons, and about 5 of which are similar in size to they're similar to the size of the 6 regular moons around Saturn, so about 500 to 1600 kilometers in diameter. And its ring and moon system is pretty interesting because it's tilted at 98 degrees. Okay, so we talked about this last time that Uranus is on its side, it's tilted on its side. So that's how its moons are as well, and rings. So in this image, you can kind of see that, right? You can see that it has been rotated so that um, the moons are not horizontal, but instead almost vertical. Okay, so these are a few of its moons. Not stuff. Let's see. I don't have anything super interesting to talk about with them. It's something that we still need to study. Okay, um, but I think the most interesting thing would be that they are again tilted at such a high degree and pretty much at um, a vertical position rather than horizontal. Okay, all right. Lastly, let's talk about Neptune's moon. So there are 14 known moons of Neptune. The rings are narrow and faint. We mentioned that last time. And the one moon that we will talk about is Triton. So Triton is a relatively large moon and is in retrograde motion or orbits the opposite direction of Neptune's rotation. Okay. It has a very thin atmosphere and has had active eruptions that were discovered by Voyager in the 1989 flyby. So if we look at this again, um, it has synchronous rotation with Neptune, like all these other planets that we've been talking about. It's sparsely cratered surface with smooth volcanic plains. So you can see that difference here. So these are relatively smooth plains. They're actually in between here too. And then we have some crater-like surfaces. Okay. Um, Volcanic plains, mounds, round pits formed by icy lava flows, and contains more rock in its interior due to its higher density. And like I said before, has a very thin atmosphere composed of nitrogen and small amounts of methane, which the methane is going to be from the um, volcanic activity. So one thing is pretty cool is we have in this image a geyser here. Okay, so a geyser is um, when we have a heating of some sort of liquid. On Earth, it is a heating of water and probably mixed with some other stuff from a volcano. And suddenly the geyser will go off and we will get some sort of this looks like a plume of smoke or something, but in reality, it's like vapor, vaporized gases. Okay, so this is what we're seeing on Triton, which is really cool. That means that there's definitely some volcanic activity happening, um, and it's a place that is definitely um, a good idea for future study. Now, as far as life existing here, mm, I don't know. I don't remember seeing anything on NASA's website about it, but I may have mistaken. But given that it doesn't have anything about having um, a water source of any kind, whether it's beneath the surface, above the surface, ice, don't have a lot of information on that. And that's probably due to not having a ton of data available on Triton yet. Okay, so hopefully we can get some more in the future, um, getting some more spacecraft out there. All right, so I'm going to pause here and then we'll continue with Pluto in the next one.